Okay. So today we're talking about section 6.5, which is called Exponential and Logarithmic Equations. So we've already been solving some exponential equations and some logarithmic equations, but these are going to be the harder problems. There's no list of steps that I can give you to solve these, but they all follow some similar patterns. So we're going to see some patterns emerge as we start solving these. I think we're going through 3 exponential equations and then 4 logarithmic equations. Typically, the logarithmic equations are the more difficult ones. All right, so let's look at our first example. We're going to start with exponential equations. I'll give you a minute to write these down. It says, solve each of the following exponential equations. Express your answer as both an exact expression and a decimal approximation, rounded to 2 decimal places. So I just copied these directions straight from the homework. On the test, I'll just have you round your answer or write your answer as a decimal. So on the test, we'll do decimal approximations. But the homework will have 2 little parts. They'll have one part where you write an exact expression. That just means as a fraction. And then the second part will be typing that expression into the calculator and getting a decimal approximation. The first example is 7 raised to the 2x minus 8 equals 1,167. We can see this is obviously an exponential equation. It's got a variable in the exponent. We learned one method for solving these exponential equations, which was to try to make both sides have the same base, if you can. And if this on the right-hand side was something like 49, we could easily write this as 7 to the 2nd power. But this is not a number that we can easily think of in our head as writing it as 7 to some power. So we need to find another approach. The approach to these is pretty simple. There's 2 things you may end up doing. So either take the log of both sides, the common log, or the natural log of both sides. Then use properties of logarithms to simplify. Sorry, I'm in front of the board. So we're either going to take the log or the natural log of both sides. Then we're going to use properties of logarithms to simplify. We learned those 3 properties the other day, the product rule, the power rule, and the quotient rule. So we'll use those properties to simplify these expressions. So how do you know whether you should take the log or the natural log? It literally does not matter. It does not matter at all. Typically, the only time that I take the natural log of both sides is whenever I have a base of e. So you can see on the next problem, when you've got an e in the problem, that's when I take the natural log. Otherwise, I just take the log of both sides. All right, so here's how it goes. You're going to do log of the left-hand side equals log of the right-hand side. Since we're taking log of both sides, we're not changing the equation at all. We're not altering anything. Now, one of our properties of logarithms was the power rule. The power rule tells us that if we have log of a number to some power, that we can take that exponent and just pop it right out front. Y'all remember that property from last week? Now you're going to have to be careful here. You want to make sure to put that exponent in parentheses. So put a little parentheses, 2x minus 8. Then everything else will stay the same. Log of 7 equals log of 1167. From here on out, we're just solving this like it's a regular old linear equation. So we're going to distribute on the left-hand side, multiply through. So go ahead and multiply through there. Your whole goal from this point out is just to get x by itself. So that's going to be 2x times log of 7. Don't plug anything in the calculator to the very last step. Minus 8 times log of 7 equals log of 1167. All right, trying to get x by itself. So go ahead and move this 8 times log of 7 over. We're going to add that. You don't have to put the little dot between the 8 and the log of 7 if you don't want to. Okay. That goes away. So now we have 2x times log of 7 equals log of 1167 plus 8 times log of 7. It looks awful. These all will have answers that look absolutely awful. Trying to get x by itself. We're almost done. We just need to divide by the stuff that's attached to x. All right, so divide by the 2 and the log of 7. So divide by 2 times the log of 7. You can put the little dot in there again. Divide by 2 times log of 7. Right, so that's going to cancel out the 2 over here and cancel out the log of 7. Now all you're left with is x on the left-hand side. Which is what we want. Now the right-hand side, this would be the exact expression. So like I said on Hawks, this will be the first part of your answer. You don't have to worry about simplifying anything here. So this would be the exact expression that they want in the answer, in the first answer box. But like I said on the test, I'm just going to have you write this as a decimal. So let's practice plugging this in the calculator. So go ahead and get your calculator out. Like reduce. You could, if you separate this into 2 fractions. So if you wrote it as like log of 1167 over 2 times log of 7 plus. So if you did it like that, then you could reduce. But you can't reduce unless you separate them. So if you wrote it like this, then these log of 7s would cancel, right? And this would reduce to 4. So you can do that if you want to. You can leave it as the big fraction if you want to also, that's fine. Just erase that because it was kind of sloppy. All right, let's plug this in the calculator. All right. These are always going to be these like massive expressions, so be really careful when you plug them in the calculator. This would be like a situation where you want to do submit your written work on the test, because if you have the answer written down correctly and all you did was plug it in the calculator wrong, I'm still going to give you the credit for it. All right, so if you have a TI-83, make sure you put that entire numerator in parentheses. Okay, make sure you put everything in the numerator and in the denominator in parentheses. So do a little parentheses here. Do a little parentheses here. If you got a TI-84, we have that little fraction button we can use. So we can do alpha y equals or alpha x on some of your calculators. Click the first option, which is numerator over denominator. And I've already forgot my stuff to plug in. Log of 1167 plus log of 7. Actually, log 1167 plus 8 times log of 7. Oh, shoot. All right, and then 2 times log of 7 in the denominator. And there's our decimal approximation. Did y'all get that? Yeah. Cool. All right, they said 2 decimal places, so that would be 5.81. 5.81. That would be the answer for the test. So this is kind of like a 2-part deal on homework. All right, so like I said, when you have these complicated exponential equations, your approach every time is going to be to either take the log of both sides or the natural log of both sides. You're only going to do the natural log of both sides, or it only really helps you to take the natural log of both sides when you have an e in the problem. So here we have 2 times e to the negative 2x plus 12 equals 120. Definitely an exponential equation. It's got variables in the exponent. Your first step, which kind of reminds me of, which I guess this was back when we talked about exponential equations. I told you we need to have the exponential expression isolated. So we need to move that 2 over. That's going to be your first step. And then we can take the natural log of both sides. All right, so we have 2 times e to the negative 2x plus 12 equals 120. First step, like I said, is divide both sides by 2. Get that exponential expression by itself. So you have e to the negative 2x plus 12 equals 60. Now these are going to be a lot easier than the last one, and you're going to see why in just a second. Let's take the natural log of both sides. So we're going to do natural log of the left equals natural log of the right. So hopefully you remember when we did some of these type of equations last week, I told you that you almost always, or it will almost always help you to change natural log to log base e. So go ahead on the left-hand side only, change this to a log base e. It's the same thing. ln is just our abbreviation for log base e. You can leave that ln on the right. Remember, one of our properties of logarithms said that if the base matches the argument, they cancel out. So if your base here matches the base of your argument, then they cancel each other out. And you're just left with the exponent. So that's why we didn't need to worry about changing the right-hand side. Nothing's going to cancel over there. But we changed it to log base e on the left because we know that the base matches the base of the argument. That's going to cancel stuff out. Now, you don't have to write in that step. You can just remember in your head that ln and e cancel each other. So if you're doing this on your own, just remember ln and e are inverses. They cancel each other out. From here, it's pretty simple. We're just going to subtract 12 and then divide by negative 2. All right, so let's do that. Subtract 12. Then divide both sides by -2. So we have x equals, this is our exact expression, natural log of 60, close parentheses, minus 12 over -2. Now let's plug that in the calculator and see what the decimal approximation is for that. I like this one. I think this is one I'll put on the test. All right, so make sure you know how to do that one. I want to say I put it on the practice test also. All right, so natural log of 60 minus 12 over -2. Again, if you have a TI-83, make sure you put that whole numerator in parentheses. You don't have to put the denominator in parentheses here, but it's good practice just to always do that. All right, so alpha y equals ln of 60, close those parentheses, minus 12 over -2. Did y'all get that? Yeah. That's 3.95.
With the TI, I have to put the denominator in parentheses too, or it won't be null.
Yeah,
I have to do both.
yeah, it's very annoying. Yeah, so always do parentheses around the top, parentheses around the bottom when you have a TI-83. Right, so there's my two answers. Again, this is like the exact, this is the approximation. I think we have one more. Oh yeah, this next one is the hardest one on homework, I would say. Of all the questions on homework, this is probably the hardest. It's just a lot of algebra, a lot of, trying to get x by itself. The actual exponential part isn't the complicated part, it's the solving for x. After we make it into a linear equation, it's hard. All right, so we have e to the 3x minus 10 equals 124 to the 2x minus 1. Anytime you see an exponential expression in both sides, typically those are harder. So when you have variables in the exponent on both sides, those are usually the harder ones. We have an e in this problem, so we know we're going to take the natural log of both sides. That's going to help us cancel stuff out. We can see that our exponential expressions are isolated, so we don't need to divide by anything. So we'll go ahead and take the natural log of both sides. We know that ln and e cancel each other out, so go ahead and cancel that on the left. Ln, natural log, and e are inverses, so they cancel each other out. So you're left with just 3x minus 10 on the left. We got this whole big expression on the right. All right, so we're trying to get x by itself. Go ahead and use the power rule to bring the exponent out front over here. Just in front of its logarithm, not like all the way to the front. Just in front of its logarithm. So we got 3x minus 10. That didn't change. Now we're going to put the 2x minus 1 in parentheses out front. Times ln of 124. I'm just going to write that as a cursive L so it doesn't look like a 1. So we got a lot of things going on right now. All right, so this kind of looks similar to what we did in number 1. Remember we had to distribute. So let's do that now. We're going to distribute on the right-hand side this time. Sorry for all those little extra marks. Left-hand side is staying the same. We got 3x minus 10 have 2x times ln of 124 minus 1 times ln of 124. Do we need to write the 1 times? What's 1 times ln of 124? Just ln of 124, right? So we can really just write this as minus natural log of 124. Okay. Trying to get x by itself. So we're going to move everything that's got an x on it to one side, move all the other things to the other side. I'm going to move the x's to the left, and I'll move everything else to the right. So go ahead and move this 10 over, add it to the end, get rid of that. You can probably, if you're doing this on your own, do multiple steps at once. I'm just writing this out one step at a time. You're going to have to move this whole expression to the left. So minus 2x times ln of 124. Move that to the other side. So that cancels out over here. All right, so on the left, we have 3x minus 2x times ln, or natural log of 124. Right-hand side, we have, be careful here, that's a negative natural log of 124, that's a 3. Plus 10. All right, so here's where it gets a little bit messy. We have an x here, we have an x here. We can't just do 3x minus 2x is 1x because this x has the natural log of 124 attached. So we're going to have to actually factor out an x. So you're going to factor out an x. What's left over if we pull out x? What's left over in this first part?
3.
It's just a 3, right? What about in the next part? 2. And what else?
ln.
Yep. 2 and the ln of 124. Or natural log of 124. So it looks absolutely terrible. From here, it's all easy. I would say that that is the hardest part to remember, is to factor out an x at this step. So I'm just going to write ourselves a little note here. That's what we did. Factor out x. All right, so trying to get x by itself, just divide by the stuff that you're multiplying by x. So divide by all this stuff that's being multiplied by x. Don't try to simplify anything. You don't want to do like 3 minus 2, just 1. Again, because 2's got that ln of 124 attached. All right, so we have, here's our exact expression. X equals negative natural log of 124 plus 10. All over 3 minus 2 times the natural log of 124. You can't cancel the natural log of 124 because we've got this extra stuff in our fraction. We got the plus 10, we got the 3 minus. So don't try to cancel anything. Let's just put this in the calculator. Again, make sure you put parentheses around the top, parentheses around the bottom for your TI-83. Okay. Negative natural log of 124 plus 10. All right, so alpha y equals, oh shoot, I did it again. 124, negative 124, negative 124 plus 10 over, what's in the bottom?
3 minus 2.
Sweet, okay. Negative 0.78. Negative 0.78. Okay. You always, even on the test, you'll wait for the last step to plug it in the calculator. There's our two answers.
Will that one like that be on the test?
No. No. The one from the test will look more like that one. I think that's totally reasonable for the test. This is unreasonable for the test. This is like aggressively exponential. Yes, this is much, much harder than the one you'll see on the test. All right, so that's everything for exponential equations. Next, we're going to talk about logarithmic equations. You're going to see two distinct types of problems here. They're very easy to distinguish between. They're going to look different. All right, so the two types of problems you'll see here are where you have some kind of logarithmic expression equal to a number. And then you'll have, on some of them, logarithmic expression equal to a logarithmic expression. You're going to solve these two types of problems differently. If you have a logarithmic expression equal to a number, then you're going to use the definition of a logarithm. Which, if y'all remember from last week, that was this definition. Remember I told you you're definitely going to want to write this on your index card. For the test, you're going to use it a whole bunch. So when you have log or some kind of logarithmic expression equal to a number, you're going to use the definition of a logarithm, which is y equals log base a of x is equivalent to x equals a to the y. And if you have log equal to a log, so if you've got logarithms on both sides, then these are going to be easy. You just set the arguments equal to each other. So I think we're going to do two of each type.
You mean something base?
No, the actual argument of the logarithm. So it'll be like, you might have log base 7 of x equals log base 7 of 2. And so like this part inside the parentheses is called the argument. So in that example, your answer would just be 2. So when you've got logs on both sides, these are nice and easy. Now, they're not always going to be that easy. Typically, you'll have more than one logarithm, and we have to use those rules that we learned about logarithms to condense them. But this is the general idea. All right, so let's look at our examples. Here's the first one. Oh, and on these, we have to check our answer. So let's add that here. You must check your answer. And I'm going to show you kind of like a little sheet for how you can check your answer quickly. The most important thing here is that you don't want to ever plug a negative number into a logarithm. So that's really what you're checking for. You're checking to make sure I don't want to be plugging a negative number into a logarithm, so that's what you're checking. All right, directions, really long. Solve each of the following logarithmic expressions. Express your answer as both an exact expression and a decimal approximation, rounded to, actually it's just these 4 decimal places. If there's no solution, then write no solution. I can go ahead and tell you that none of the questions on the test will have the answer no solution. There will be no questions on the test where the answer is no solution. And again, same with exponential. On the test, I'll be having you do decimal approximations instead of exact answers. All right, so this one is an example where we have logarithms equal to numbers. So we're going to use the definition of logarithm here. But in order for us to use the definition of logarithm, this needs to be one logarithmic expression. So we need to condense that left-hand side. We practiced that last week. I think that was section 6.4. All right, so this one says log base 5 of x minus 1 minus log base 5 of x minus 3 equals 3. It's very important in these situations that the bases be the same. If they're not the same, there's nothing you can do. All right, so that's the first thing you're checking for. Make sure the bases are the same. They are here. So we're going to condense the left-hand side. I'm abbreviating that LHS left-hand side. So condense the left-hand side into one single logarithmic expression. These are separated by a minus, so that means we're going to use the quotient rule. So we're using the quotient rule here. Since they are separated by a minus. So that's going to be log base 5 of, this is going to be our numerator, this is going to be our denominator. So it's going to be x minus 1 over x minus 3. And again, that's the quotient rule. Right hand side stays the same. We've now got this in the form of a single logarithm equal to a number. So we can now just go ahead and apply the definition of a logarithm, which looks like this. So this is why we practiced last week converting between exponential form and logarithmic form, because we're going to be using it here, using that skill. All right, so we can see that A is 5, x is going to get replaced by x minus 1 over x minus 3, and y is 3. All right, so we have x is x minus 1 over x minus 3 equals a to the y, so that's 5 to the third. Go ahead and simplify any like powers that you have. What's 5 to the third? That 125? All right, now we're just trying to get x by itself. So the first thing standing in our way is this denominator. So go ahead and multiply both sides by that denominator. That's going to cancel out on the left. Then you have x minus 1 equals, let's distribute that. So it's going to be 125x minus, is that 6? I don't know what that is. Let's see. 125 times 3. 375? Thank you. I was going to say 625, so I was like, oh. Okay. We're almost done. This is, from here on out, it's super easy. Let's see, move the numbers to the right, we'll move the x's to the left. So add 1. Be careful here because we got a bunch of negatives going on. That gives us x equals 125x minus 374, because that's negative 375 plus 1. Subtract 125x from both sides. So that's negative 124x equals negative 374. I don't know if this simplifies or not, we'll see. Let's see. Negative 3. Let me do it on the screen. Negative 374 over negative 124. Right, fraction. Yeah, it does simplify. 187 over 62. So I just went to math and then hit frac, which was the first option. And there's our decimal approximation as well. They wanted 4 decimal places for these. So it's going to be 3.0161. Okay. 187 over 62. So x is 187 over 62. Why is it positive? Yeah, the negatives cancel. That's the exact answer. The approximation was 3.0161. My pinky hit the board. So exact and then approximation. I'm trying to think of which one I put on the test. I'll tell you when we get to the part D, because I remember after I see all of them. Okay, we have all the same base here. That's a good first thing to check. They're all base 4. So we got log base 4 of 2x minus 7 plus log base 4 of x equals log base 4 of 3. So we got logs on both sides here. Those are typically the easier problems. Our first and only major job here is just going to be to condense the left-hand side. Make it into a single logarithm. So we got log base 4 of 2x minus 7 plus log base 4 of x equals log base 4 of 3. All right, so we're going to condense the left-hand side. This time they're separated with a plus, which means we're using product rule. Again, these were all the properties of logarithms from section 6.4. So that means the arguments, the step inside the parentheses, is going to become a product. We're going to multiply them. So it's going to be log base 4 of 2x minus 7 times x equals log base 4 of 3. Right hand side did not change. All right, so now we have log base 4 on the left, log base 4 on the right. So just set the arguments equal to each other. So this part and this part. So we have 2x minus 7 times x equals 3. Much easier to solve. I'm just going to multiply through by x here. This is going to be a quadratic equation. So we have 2x squared minus 7x equals 3. Go ahead and move that 3 over to the left-hand side. You're either going to want to factor here or use quadratic formula. This one doesn't look, well, let's see. I think this one will factor. Maybe not. Let's just use quadratic formula just to avoid having to figure out if it factors or not. All right, so here's the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If you don't have that memorized, you might want to write that on your index card. I think I told y'all, I may have not have, but when I was in the 9th grade, our teacher made us stand, every one of us in the class had to stand in front of the class and sing the quadratic formula to the tune of row, 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 vote. And so I cannot forget it now because it is a very traumatic memory for me. So even if I wanted to, I do not think I could forget it. So believe it or not, I do not have a beautiful singing voice. All right, so A is 2. What is B? Negative 7. C is negative 3. All right, so let's plug those in. All right, so we got X is equal to positive 7, because negative 7 would be positive, plus or minus the square root of negative 7 squared minus 4 times A times C all over 2 times A. I like to go ahead and simplify the radicand first, so the stuff under the radical. So I'm going to plug that into my calculator. All right, negative 7 squared. All right, negative 7 squared minus 4 times 2 times negative 3. Ugh, it's not a perfect square. That's okay. So this actually wouldn't have factored, so it's a good thing we use quadratic formula. All right, so just positive 73 under the radical. Two times 2 is 4 in the denominator. There's our exact answer. Now, don't forget we have to check our answers. So let us see here. I'm just going to split this up into 2 parts. Let me go to make a new page because I don't want this to get super small. Okay, so let's separate this into 2 pieces. We're going to have x equals 7 plus square root of 73 over 4, and x equals 7 minus the square root of 73 over 4. All right, so those are 2 answers. Remember, we don't want to plug negative numbers into radicals. We're not allowed to. So this looks like it's going to be positive, right? 7 plus square root of 73 divided by 4. But this may be negative, so let's check that one. 7 minus square root of 73 over 4. All right, so 7 minus square root of 73 over 4. Oh yeah, that's negative. So we have to throw that answer out. Not allowed to plug negative numbers into radicals. So that answer is going to get thrown out. All right, we'll just add ourselves a little note there. Not allowed. Not allowed to plug negatives. Did I say into radicals? I meant to say into logarithms. You're not allowed to plug negative numbers into logarithms. Those are undefined. So that's all we're really checking for when we check our answer. Just check and make sure that you're not plugging in a negative. Otherwise, you're going to be fine. So that one's fine. We have no negatives there. 7 plus a positive number divided by a positive number will be a positive number. All right, so let's get the decimal approximation for that. 7 plus square root of 73 over 4. So 3.8860. 3.8860. So there's my exact answer and my approximation. Any questions? Whoops. Okay, all right. I want to say that I put either C or D on the test. I can't remember which one. I want to say it was D though. I think I put D on the test. But like I said, I'll tell you at the very end which ones I think I put on the test.
That's fair.
We
only have 2 minutes left.
Oh gosh. All right. Let's do this one really quick and then we will adjourn. Let's do part D actually, since I think that's the one we're going to do. Yes. All right. This one's super easy. Actually already set up perfectly for us to solve it. We have natural log of x minus 2 equals natural log of 5x. We have a log equal to a log. So just set the arguments equal to each other. No extra work to do here. Thank you for telling me. So just set the insides equal to each other. Super easy to solve, just subtract x, divide by 4. Oh, x is negative 1/2. Are we allowed to plug negatives into logarithms? No, so this is no solution. The one on the test will have a solution. So we're not allowed to plug negatives into logarithms. All right. Let me stop the recording, and then I'll really quickly talk about the test.